Hello friends, in this video I will explain how to make a CDI and ignition coil testing machine, which can be used for testing CDIs and ignition coil of all motorcycles, two-wheelers, and three-wheeler vehicles. So let us learn the details through the following explanation. To build this circuit at home, you will need to buy the following components. 1. 60 ohm, 1 watt resistor, 1. 100 ohm, 1 watt resistor. 71N4007 diodes. 1 microfarad 400 volts PPC capacitor. 1 BT151 SCR, Philips made. 2 transformers, rated at 12 voltage 500 milliamperes. 1 ignition coil, which are normally used in two-wheeler vehicles. Next, you will need to assemble these parts over a neat-looking PCB, which would finally look like this. Now, let us understand how the entire CDI tester setup works. First, let us see how the transformer connections are wired up. You can see on the right side there are two 12V012V, 500 mA transformers. The first transformer takes two 20 volts mains AC input and steps it down to 12 volts AC. The second transformer is connected in reverse, meaning its 12V winding is tied to the 12V of the first transformer. So the secondary of the second transformer now generates about 220V AC at very low current on its primary side. This gives a safe, isolated, low current 220V AC output, similar to the alternator output of a bike. Now we can see a bridge rectifier section also on the top right. Here the 41N4007 diodes form a bridge rectifier that converts the low current 220 volts AC from the second transformer into DC, roughly 310 volts DC peak. This DC is supplied to the CDI circuit to charge its main capacitor, C1. Now let's talk about the CDI circuit section. On the left side, we have the SCR, resistors, R1, R2, and capacitor C1. C1 is the main discharge capacitor. It gets charged by the rectified DC. Now the important part. The main purpose of the bridge rectifier is to convert the 12 volts AC into 12V pulsed DC. Because 12 volts AC has 50 Hz frequency, after full wave rectification it becomes pulsed DC at 100 Hz. That means we get 2 DC pulses for each AC cycle. So this pulsed DC is applied to the trigger input section of the CDI circuit. Now every time this pulsed DC hits the SCR gate input, then the SCR turns on for a moment and discharges the main capacitor C1 through the ignition coil. So the ignition coil keeps firing sparks one after another at the same 100 Hz rate. SCR1 acts as a switch that discharges C1 through the ignition coil's primary winding whenever triggered. The ignition coil steps up that pulse to several kilovolts, creating a spark at the plug terminal. When we see the sparks being generated continuously at the 100 Hz rate, we can be sure that the CDI circuit being tested is good and in a proper working condition. Alternatively, we can also use this tester to test ignition coils. In this situation, the CDI circuit becomes the default fixed element in the setup, while the ignition coil becomes the element to be tested. So friends, that concludes our explanation regarding how to build your own CDI tester circuit for testing all types of vehicle CDI units. If you have related questions, please do not forget to ask them in the comments below. Thank you for watching.